So in this section here, we're going to be simplifying rational expressions, which basically is reducing fractions, is what we would call it in more lower level maths. So simplifying rational expressions basically means reducing fractions. So remember, if I gave you, say, 12 over 20, if I want to reduce this, what we could do is we could prime factorization. In other words, rewrite the 12 as a factorization, and I can write the 20 as a factorization. Remember, 2, 3, 5, 7, 11, 13 are most commonly used to break numbers down. So if I look at this 2, it does go into 12. 2 goes into 12 6 times. But notice how 6 is actually factorable. 2 goes into 6 3 times. But 2 doesn't go into 3, but 3 does go into 3. 3 goes into 3 one time. So notice that 2 times 2 times 3 is another way to write 12 as a factorization. If you look at the 20, 2 does go into 20 10 times. 10 is factorable. 2 goes into 10 5 times. Notice that neither 2 nor 3 go into 5, but 5 does go into 5 one time. So I could change this to 2 times 2 times 5. In math, when you reduce fractions, you're essentially using division. You're going to divide out like factors. So notice that 2 divided by 2, that turns into a 1. 2 divided by 2 turns into 1. So essentially what we're doing is canceling those out. But when multiplied by 1, notice that it's an identity element. Multiplying by 1 does not change the identity, so this stays as 3/5. So reducing fractions, you kind of see that we're factoring and then canceling. So if I want to reduce this rational expression, notice how we have a binomial divided by a trinomial. We want to apply our factorizations. So if we look at this y squared minus 36, that looks like a binomial. So that looks like this difference of squares. So again, if I want to see if 36 is a perfect square, you could actually use your calculator and take the square root of it. So remember the inverse, notice how there's square and square root. If you take the square root of 36, if you get a whole number, that means it's a perfect square. So notice how I get 6. So if I do 6 squared, notice how that gives me 36. So that means that this is a difference of squares. So I can apply this formula here that says a squared minus b squared, where notice how the a is the y, and the b is actually the 6. So it's going to be y minus 6 times then this y plus 6 becomes the factorization of the top. On the bottom, we have a trinomial. Notice how there's a coefficient in front of the y squared. But it looks like all three terms could possibly be divided by this 9. So it could actually be a common factor. I do know that 9 goes into 27 3 times, but I'm unsure about the 162. So if we use our calculator and go 162 divided by 9, notice how we get this 18. So that means that I can actually factor a 9 out of this. So what we're going to do is pull a 9 out. So if I divide a 9 out of the 9y squared, that's going to just leave me the y squared. If I divide negative 27 by the 9, that's going to leave me this negative 3 with the y. And then the negative 162 divided by the 9, that's going to be that 18. And since it's positive, it's going to be a minus 18 there, I should say. So notice that if you multiply the 9 back through, 9 times y squared does give me 9y squared. 9 times negative 3y is negative 27y. And 9 times negative 18 would be this negative 162. Now, I can actually rewrite the top again, come down one more time, y minus 6, and then y plus 6 on the top. On the bottom, this 9 comes down. But the question is y squared minus 3y minus 18, is that factorable? So notice that if we use our little chart, that's going to be kind of like this one right here. Notice how there is no, there's a 1 in front of the quadratic term. the second degree term. So basically all I gotta do is focus on the factors of the constant that add up to give me this this linear term coefficient, the b. So in other words, the factors of c that add up to give me this b, if you want to use just their language there. So if I look at this negative 18, so what I'm looking for are the factors of this negative 18, but they have to add up to give me this negative 3. So we have 1 and 18, 2 times 9, 3 times 6, 4, no, 5, no, 6, no. So wait a minute, 6 times 3, yes. That's just repeating now. So those are my 3 different options. But to get a negative 3, it looks like this 3 and 6 look like the best choices. But to get a negative 18, one of them's got to be negative. And to get a negative 3, the bigger number's got to be negative. So when I multiply this 3 times the 6, it actually has to be 3 times negative 6. 3 times negative 6 is negative 18. 3 plus negative 6 is negative 3. So that's going to be my winner. So when I factor my y squared minus my 3y minus 18, it's going to factor into 2 binomials. So I have my y and my y because that's going to give me more y squared. And then this 3 and this negative 6 become my constant, my last terms, my plus 3 and my minus 6. Once we have that, then we can kind of start trying to look for common factors on the top and the bottom. Notice how they both do have a y minus 6 on the top and bottom, so I can actually reduce that. And that's going to leave me then, the remaining factor on the top would be then this y plus 6. And on the bottom, we have this 9 times the expression y plus 3. So that's what we would have as our answer there. So that's the key to simplifying rational expressions, is use our factoring strategies, cancel out like factors, and then write what's left. That's kind of your steps there. Okay. So you kind of see that you have to factor the numerator and the denominator, and then you want to cancel, and then you're going to write what's remaining. So we have that kind of as a quick kind of a snapshot of what we're doing. Factor, cancel, and then the remaining would be your final answer there.